JEE Advanced 2021, Paper 1, Question 18. Physics, Rotational Dynamics. Let us visualize the setup. A thin rod of mass m and length r is free to rotate in a horizontal plane about a fixed vertical axis passing through point O at one end. A thin circular disk, also of mass m, with radius a over 4, is pivoted on this rod. The center of the disk is at a distance a over 4 from the free end of the rod. So the disk's center is at 3 a over 4 from the pivot O. The rod rotates with angular velocity capital omega, and the disk spins about its own vertical axis with angular velocity 4 omega, as seen by a stationary observer. The question asks, the total angular momentum of the system about point O is ma squared omega over 48, multiplied by n, find the value of n. The key concept here is the total angular momentum about point O. It has three parts. First, the angular momentum of the rod rotating about O. Second, the orbital angular momentum of the disk, because its center moves in a circle of radius 3 a over 4 about O. And third, the spin angular momentum of the disk about its own axis, which rotates at 4 omega as seen by the stationary observer. Step 1. The rod's angular momentum about O. The moment of inertia of a uniform thin rod about one end is ma squared over 3. So the rod's angular momentum is ma squared omega over 3. Converting to 48s, this equals 16 ma squared omega over 48. Step 2. The disk's orbital angular momentum about O. The disk's center is located at a minus a over 4, which equals 3 a over 4 from O. Since the disk rides on the rod, its center moves in a circle of radius 3 a over 4 with angular velocity omega. So the orbital angular momentum is m times 3 a over 4 all squared times omega. That gives 9 ma squared omega over 16, which equals 27 ma squared omega over 48. Step 3. The disk's spin angular momentum about its own axis. The moment of inertia of a thin circular disk about its central axis is 1/2 mr squared. Here, the radius is a over 4, so the moment of inertia is ma squared over 32. The disk spins at 4 omega, so the spin angular momentum is ma squared over 32 times 4 omega, which simplifies to ma squared omega over 8, or 6 ma squared omega over 48. Step 4. Adding all three contributions. We have 16 over 48 from the rod, 27 over 48 from the disk's orbital motion, and 6 over 48 from the disk's spin. Adding these, 16 plus 27 plus 6 equals 49. So the total angular momentum is 49 ma squared omega over 48. The answer is n equals 49. The total angular momentum of the rod disk system about point O is 49 ma squared omega over 48. The largest contribution comes from the disk's orbital motion, 27 out of 49 parts. Exam tips for JEE Advanced. Tip 1. When a disk is mounted on a rotating rod, always separate the angular momentum into orbital and spin components. Tip 2. The angular velocity given, 4 omega, is the absolute angular velocity of the disk as seen by the stationary observer, not relative to the rod. Tip 3. Convert all fractions to a common denominator to avoid arithmetic errors. And remember the standard moment of inertia formulas, ma squared over 3 for a rod about one end and mr squared over 2 for a disk about its axis. If you found this helpful, like and subscribe for more JEE Advanced solutions at MAGPIEHUB.